So everyone, small change in schedule. Everyone expecting Arun Gupta will be disappointed, but we have Ray Tsang instead.
Thank you. Thank you. I'm sorry. Is this on, by the way? Yeah? Okay, very good. Awesome. Very happy to be here. I know Arun is not feeling so well, so I'm happy to be able to stand in for this session. Unfortunately, I'm going to talk just about Kubernetes. And just before I begin, I'd like to mention Lars Morgan is actually in the audience here. Lars is writing a lot of stuff on Kubernetes stuff and also running it on ARMS, Raspberry Pi clusters. So I'm very happy that he's here. If you want to check it out on all the crazy things he's able to do, definitely have a talk with him. All right, cool. And let me get started. So today we're going to talk a little bit about Kubernetes and mostly about Kubernetes API, which is a feature or a way to extend the functionality of Kubernetes that a lot of people don't really know about or haven't really used. And my name is Ray. I'm a developer advocate for the Google Cloud Platform. And what I like to do is to bring some of our technologies, open source and cloud, to developers all over the world. And I love to hear about your experiences and your feedback. So if you have any questions, please contact me on Twitter @Satanism. And if you'd like to see some of the travels I do a lot of traveling and I take a lot of photos. You can check it out on flickr.com. So I just want to mention that autoscaling is actually a built-in feature now directly in Kubernetes as part of the standard thing. And you can do horizontal pod autoscaling based on the CPU utilization and custom metrics. And you can learn more about how to do that exactly in the website. But today I'm going to show you how to actually use the API to write something yourself. And it really helps open up the possibilities in using some of these container orchestration systems. Now, when I was writing this autoscaler for the first time, that was about, I think, a year and a half, 2 years ago. That was before they had this feature. Okay, they had no such feature before, and thought, hey, wouldn't it be nice for me to try this out? And just keep in mind, I've never written an autoscaler before prior to that. So that was the very first time doing it, and it was pretty fun. So I'd like to share some of the things I learned in doing so. Okay, so what am I trying to autoscale today? Well, I'm going to try to play around with a distributed in-memory cache. Okay. And there are many of them out there today. I mean, there's InfiniteSpan, Hazelcast. I know the Hazelcast engineer is here as well. So I don't know what people use today, but I used to work at Red Hat prior, and I used to work a lot with InfiniteSpan, so I was very, very familiar with it. And so I thought, hey, that's an interesting problem to tackle, and so I give it a try. I give it a shot. Anyone here use InfiniteSpan before or currently? No, very few. Okay. So it is a distributed in-memory cache. It's a key value, what they call a NoSQL store, but it's really, I treat it as an in-memory cache mostly. I mean, you can persist data if you want, but it has this wonderful, wonderful elastic property. What do I mean by that? Well, in a cache, if you're running on a single node, and if you are out of heap, well, that's too bad, right? But in some of these distributed caching technologies, right, you can actually just add another node to it, and it's running a different instance or a different machine with more memory, and all of a sudden you're looking at a cluster of nodes as a single cache. And they can distribute the entries across multiple nodes. Right? So if I have 3 entries, A, B, and C, it will be hopefully evenly distributed across 3 nodes. And they're built to be redundant, so that if you have an entry, they will replicate the entry on another instance, for example, just to make sure that in case one of the instances goes down, you still have the data, right? And it will actually auto-rebalance the data for you behind the scenes. So now even though one instance went down, you still have two copies of the data. If you are running out of capacity and you need more memory, more heap for this distributed cache, all you need to do is to add another node right into the cluster. They will actually usually perform some kind of discovery to discover all of the other nodes within the cluster. And once that's all discovered, then the system will rebalance itself again, and making sure that, again, you have the number of copies that you need across the entire system. Okay? So it's pretty nice. It's a nice way to illustrate the elasticity of a more or less a stateful but in-memory workload. Then I thought, hey, wouldn't it be nice if I could autoscale this, right? And that was kind of like my inception into autoscaling. Because once you get into this topic, it kind of goes on and on and on as deep as you want. And I was caught in this fascinating world in a few months. So I'll let you know a little bit about what I learned. But keep in mind, again, this is the first time I ever done this, right? So here's what I learned from autoscaling. There is a class of workloads that's really easy to autoscale, right? I mean, we, as developers, right, we always wish our system just can handle itself. If there is a peak load on Mondays usually, well, just scale out automatically. What's so hard about that, right? And if somebody like marketing is running a campaign of some sort, I just wanted to autoscale and I don't have to worry about it. Now, of course, with all of these things, you have to make sure you have the capacity underneath to support and running of the system. But just the software itself, there are different classes of software that's easy, and then another classes are a little bit harder. So it is really, really easy to scale out. If you have the capacity, you can always scale out stateless workload. Okay? Stateless workloads are so easy to scale, right? That's probably the first thing that you're going to see in any of the autoscaler system, because all you have to do is to spin up another instance, do its work, and when it's done, it's stateless, just drop it. And in a lot of these systems, what you're going to see by default is that they're going to scale based on the system metrics. And most likely, what you're going to find is based on the CPU, because again, that's easy to scale to detect. It's every CPU utilization you can get either in the container or on the actual machines. So you can get that very easily, and based on the CPU utilization, you can decide that you want to scale out. And scaling out, of course, is also easier task to do. But what is difficult is to scale in based on the custom metrics, and especially for things that have state, right? Why is scaling in hard? Because scale out actually has some cost. When you're scaling out, you have to spin up more instances. And the instance startup time is the cost you have to be aware of. If the instance takes a long time to start up, then you probably don't want to scale in very aggressively, right? Because if you scale in too fast, and then 5 minutes later, there's another surge of requests, well, you gotta wait a long time for your instances to start up, then the auto-scaling thing just probably doesn't help in that case. So you gotta be careful and think about when and how you want to scale in. Especially for stateful workload, like infinite span in this case, right? When you scale in, you can actually only scale in a limited number of nodes at a time. You cannot just say, oh, well, right now I have 10 instances, let me scale in back to 5 and just kill 5 instances. Well, that wouldn't work because you might actually lose data. I'll show you why. And then custom metrics is also a little bit more difficult to do. Why? Because custom metrics, by definition, is something that's custom to your app. Well, how is your application exposing the metrics? There are so many different formats. Are you using GMX? Are you using Prometheus? Are you using Spring Actuator? Or what are you using? And does the system actually can take in that metrics? So all of these things will require some custom adaptation, right? So today, I'm only going to show you the difficult stuff. Hopefully everything works, which is to autoscale, in this case, infinite span. Not with the CPU utilization, because in a cache, right, CPU utilization is usually really low. What I need to scale is based on the memory, or based on how many entries that I can kind of guesstimate how much memory they are going to consume. So I'm going to use a custom matrix based on the number of entries in the cache per node. I'm going to be scaling in and out. Okay. So another high level of what I have learned about the autoscaling systems is that they usually follow some kind of pattern, right? The pattern is something like this. Well, first you have like a node or like instance that you want to replicate and scale out. And in this instance or this node or this kind of like a template of things, right? In this component, you have your app itself, and you need a way to collect the metrics, like a little agent to do that, or to a little agent to expose the metrics in a way that your autoscaler can understand. In this case, right, this is a push model, so the metrics collector will be pushing the metrics to a API server, a metric server that collects the metrics. You can also see it working the other way around, where you are exposing the metrics as a endpoint, and then the metric server knows where all the endpoints are and actively collects it. So that would be a pull model from the metric server. So once you have the metric server receiving these individual metrics, you got to aggregate it into some kind of store. There are many different types of, say, time series stores you can use. Whatever, like you can store this in memory because you only really need the past couple of minutes of data in most cases. So you can store it in different ways. But then the autoscaler component is the one that will actually get the aggregated metrics, like the average utilization, from the metric server and do some calculations. And here's where the magic happens, is based on the average utilization, right, and based on the configuration of some sort, it will then tell an actuator component, which is something that actually goes out and do things, right? So if my autoscaler determines that, hey, right now I'm overutilized, I need to scale out to, say, from 4 to 5 instances, then I need to tell the actuator that I need 1 more instance, or I need a total of 5. And the actuator is actually the thing that goes out to get it from the template or the component, like whatever you want to call it, that knows how to instantiate your application and the metrics collector, and then instantiate this new instance of the application. And if you look at any of the autoscaling systems, this is probably what you're going to find. For example, on Google Cloud Platform, we can autoscale your virtual machines. And well, first you gotta have a machine template, and you have to configure the instance groups and how you want to autoscale based on what kind of metrics, and just the metric server is hidden behind the scenes, for example. But you're going to find this similar pattern in most of the autoscaling systems that you're going to be working with. So since we're talking about running this in Kubernetes, well, how does it actually work? Well, in Kubernetes, there is a way for you to define what each of the running instance should look like, and that is called the pod template, okay? And you can use this template like a YAML file. You can use that and write it into, say, a higher level thing called the replication controller, replica set, or deployment, right? Basically, what you can say is you can define, each of the running instance needs to look like this, and it should have 2 different components running inside of it. And the deployment, or the replica set, or the replication controller, and Kubernetes together actually acts like an actuator, because I can easily use it to scale to the number of instances that I want. And the actual running pod, in this case, will be the running application instance. So I'll show a little bit about that in a minute. What I have to develop myself is the metric server itself, the metric store to store the data, and also the autoscaler. And I need a way to be able to have the autoscaler communicate with Kubernetes as an actuator. And the way I'm doing that is by using the Kubernetes API. Now, just keep in mind, I've never written an autoscaler before, all right? So what is Kubernetes, and how do I use the Kubernetes API? Now, just want to see a show of hand, how many people here have seen Kubernetes in action? All right, most people. Okay, awesome, awesome. Very good. So just a quick recap, right? Kubernetes is a container orchestration tool that was open sourced by Google, and it is written in Go, not in Java, but that's okay, because it runs everywhere. It actually runs everywhere natively as a native binary, and it can run on multiple clouds. So you can run it in cloud in different providers, or you can run it in your own data centers. Or if you're like Lar and me, we like to run it on Raspberry Pi clusters, right? So you can run it in many, many different places. It is based on Google's experience in terms of orchestrating large-scale distributed systems. And just a quick recap on how it works. Just remember this, right? We basically have a number of nodes, physical machines or virtual machines we want to manage. And through the Kubernetes master control plane and exposed with the API, Kubernetes master can control all of the nodes in our cluster. And as a developer, what I can do is I can push out a container image of some sort to a central registry. I can write a config file, like a template on what that application should look like when it's deployed in a config file. And I can use command line and API to tell the Kubernetes API master, hey, I need to start this, right? And then it's going to go to all the nodes and figure out which one has the capacity to run this application. And if it does, it's going to pull down the image, in this case, a Docker image, and start the container that way. Now, in Kubernetes, there's also the concept of like service discovery that can be exposed as an API, or you can use with the DNS. And also, there are many, many other constructs in there that kind of helps in terms of creating this autoscaling environment. So let's take a look at a few things. I think, first of all, I'm going to show you infinite span in this case, right? And this is a visualization tool that I've been using for a long time, a little longer than I expected, to be honest. This visualization tool is also on GitHub under the infinite span organization, okay? And what I'm going to do is that this node, this little red ball here that's running around, well, that's an infinite span node, right? So it has its own heap. And I can use a client to dump data into this node. Okay, so what I'm going to do is, well, this node is actually running in Kubernetes right now. So I'm using a replication controller, and there's the infinite span controller. And there's only one instance right now. And this instance is known as a pod, right? And this is important, again, to kind of just remember that a pod in Kubernetes is the atomic unit that it can manage and orchestrate. It is not a container. Now, a pod can be composed of multiple containers. I think that I saw a tweet recently, like, does it mean a pod is a container for containers, right? Yeah, I think that's a good way of thinking it, right? Because a pod can contain multiple containers. However, just keep in mind, the different containers in the same pod are tightly coupled together. And in my case, right, this pod actually has, you see 2 out of 2. That means there are actually 2 containers running inside of this pod. Why are there 2 containers? Because one of them is my application, which is infinite span itself. And the second container in this pod is the agent that's collecting and translating GMX metrics to my metrics server. Okay? So in this pod, I got 2 tightly coupled containers running together. And right now, it actually exposes a service. Okay, SVC, called infinite span. Now, a service in Kubernetes, usually we think about it like a load balancer. So what that means is that it will expose a single stable IP address that will then route the traffic and load balance it across all of the instances I have, or all of the pods that I have, that should be served by this stable IP. But if you look at this specific thing here, this service, like everything else kind of have an IP, right? That's a load balance IP. But this infinite span service in Kubernetes is a special service. It doesn't have any IP addresses, okay? At least it doesn't have any stable IP addresses associated with it. That is because this is a headless service. That just means that it's not a load balancing service, but it is still discoverable. What that means is I can always find out the endpoint, infinite span, that is behind this service, right? So if I have 2 pods here running infinite span, then I'll be able to see 2 endpoints. Okay. Now, let me show you why this is important, right? So in Kubernetes, I can actually use Kubernetes to scale out the number of instances. So I can say, hey, kubectl, the command line, scale the replication controller in this case. Let me have 2 instances of infinite span. Okay. And what this is going to do then is, via the API behind the scenes, right, it's actually going to tell Kubernetes to give me 2 instances. And you can see now I have 2 infinite span running, and it kind of just pops up in this view. Okay. Now, if I go to get endpoint, I should be able to see 2 IP addresses now. Okay. Now, let's add some data into it. So to do that, because it doesn't have an external IP address for me to connect to, what that means is I need to kind of get into the cluster itself, and from within the cluster, issue some commands to connect to one of these nodes to send data into it. And to do that, I can do kubectl exec. I'm going to basically drop myself into the shell in one of these running pod or one of these running containers. And now I'm inside of the container that's on one of the machines in the cluster. It doesn't matter which one, but it's within the cluster. So what that means is I can then ping InfiniSpan as a DNS name because it's exposed as a service. And so what that also means is even though it has no load balanced IP address, I can still ping the DNS name that will be automatically created for me. Okay. However, remember this IP address that you see is not the load balance IP, because if I were to ping this again, do you see that? The IPs are different. What's happening behind the scenes is that we actually created an InfiniSpan DNS name that has multiple A records, rather than having a single IP address. And this is important as well. Why? Because in InfiniSpan, or in many of these type of systems, they are self-discovering. And they also try to connect you to the instance that actually has the data within just one hop, right? So what that also means is if I were to try to connect to the nodes myself through a load balancer, that I don't know which one of these instances the load balancer is going to send me to, and then I may need to do an extra hop to another node, right? So rather than doing that, I'm just going to expose all of the nodes. And it doesn't matter which one is actually alive. Whenever I ping it, I will get a running node. And that's exactly what I'm going to use to connect. So what I can do, I have a simple Java application here. I'm going to do this hot rod dependencies. I'm going to connect to the server. And now I can just use InfiniSpan. Now, it doesn't matter which one of these nodes I connect to first, because the client will receive the topology on how to connect to any of these individual InfiniSpan instances. And I'm going to put in the entries, maybe 100 entries. Okay, so I'm going to put it in. And you can see I slowed this process down a little bit just so I can get a more dramatic visual effect. Yeah, usually it's a lot faster than this, just so you know. So now you can see we have 100 entries in each, right? 100 entries in each. Now, what if I need to scale this out? Now, there's 100 entries in each because I specified that I need at least 2 copies for each of the entries. Now, if I scale this out, if I do kubectl scale rc InfiniSpan controller to 3, how many entries should be in each of the node? Math. I suck at math. 66, I think that's about right. Yeah. So now you can see that it actually auto-rebalanced, and you can see the new node popping up, right? Yeah. Now, when you shut it down, if you say, hey, Kubernetes, I don't want 3 instances, I think 2 instances is enough, you can shut it down. So it's going to pick and choose randomly one of these instances to shut down. Now, in these systems, the shutdown needs to be graceful. Otherwise, you'll lose data, right? You could lose data. So the shutdown needs to be graceful. But because you have at least 2 copies of everything, what that means is if you just kill one of the instances, the other 2 still have all the data sets, so that's OK. So once this shutdown, because it's graceful, it's taking a little time. Once this shutdown is complete, there you go. You see only 2 instances now. And they should all realize that they have 100 data entries each, right? Now, again, it's important to remember when you do this, like you never want to go to 0, obviously. If you're only keeping 2 data entries at max copy, right? If you're keeping 2 copies, that means the maximum number of instance shutdown you can have at any given time is 1, right? If you shut down 2, there's a high chance you're going to lose data. Okay. Okay, so that's pretty cool. That's quite awesome. Now, how do I actually write a program to interact with this, to do this programmatically? Okay. Well, the good news is Kubernetes has APIs, right? I kind of mentioned this. So I'm going to connect to it through my local proxy. The way I'm doing is by using this thing called kubectl proxy. So it's built into the Kubernetes command line. You can say, I want to proxy a local port and have a secure connection into the remote master. Okay. So right now, if I do a refresh, this is authenticated communication connection into the Kubernetes master on this IP address. And I can browse into this API. I can see a list of endpoints. I can get many, many information here. The ones I'm particularly interested in is replication controllers. Okay, so that's one of the endpoints I can go. And in this replication controllers endpoint, by the way, this is all RESTful, right? All of this is RESTful. It's a JSON payload. I can actually see all of the replication controllers in here. And the one I'm interested in is the one with infinite span, this infinite span controller. And I can see the self-link, which is kind of nice. That points me directly to this. Oh, well, not that one. Let me try this again. There we go. Without the quote, maybe. Yeah, there we go. Now I can actually see the actual current status of this controller. Okay? And you can also construct this URL yourself, right? If you know the name of the resource you want to see, if you know the namespace that this resource belongs in, you can construct this URL easily. And in this current state, I can see that the replica is equal to 2. That means we have 2 instances, right? What I can also do is, of course, to do a RESTful call to this. I can do the put. I can send it a new requirement to say, rather than 2, I want 1, or maybe I want 3. Okay. So the way I'm going to do it is, where am I? Yeah, I'm in temp. So I can curl this URL. I can dump it into like a JSON file, right, temporarily. And I can open this up. I can see all the information here. And what I can do is, let me make this 3. Okay. And then what I can do is I can do a curl put. The data, which is rc.json, right? And then I need to give it a header because I need to make sure that the content type is application JSON. And then I can give it the actual URL. And hopefully that works. OK, I think that did work. Now if I go to kubectl get pod, yeah, you can see that a new instance is starting. And soon enough, this is auto rebalancing. And I just told Kubernetes to spin up another instance for me. And by the way, this is almost exactly how the kubectl command line works. It just wraps all of these API codes behind the scenes for you. Okay? Now, I need to do this from within the cluster, though, because I'm running this locally. You never want to run production environment on your local laptop, obviously, especially not an autoscaler, right? You don't want to be like, hey, I'm going to run this component on my laptop through this local proxy. Right? You don't want to do that. So what I want to do then is, well, I'm still in the cluster. I just went back to the container that's inside the cluster. Now just imagine this is my application. I'm acting manually as my application that's trying to auto-scale this, right? What am I going to do? So I can do a curl, right? Now in Kubernetes, it's going to be HTTPS endpoint, because I need to connect to the secure port now, because there's no proxy for me anymore. And you can get to a service called Kubernetes. It's a DNS name you can hit from your pods. And then you can give it this exact thing, okay? The API endpoint. So I am curling it. Wait a second. It doesn't work. Because it's using HTTPS, you need to actually give it the certificate that the server is sending you, like that you are expecting from the clients, right? Because right now it's saying, hey, I don't recognize this certificate. Are you sure this is a secure connection? Now, I have options. I can always say insecure. Don't do that. Don't do that. In fact, as all Java developers probably experienced, when you want to connect to a SSL endpoint, HTTPS endpoint, you're going to run into a lot of issues sometimes when you don't have the certificate in the CA file, right? Then what do? You override the SSL factory of some sort, and you say just ignore everything. No, don't do that. What we can do is in this running instance of the application within Kubernetes, we actually give you the certificate in a temporary directory on the var run secrets Kubernetes. And under here, we have what we call service account. And we have the actual certificate file. Okay? So what that means is, if you want to consume the API from within Kubernetes, you need to make sure you are using this certificate file. So, for example, what I can do then is, if I'm doing HTTP, curl HTTPS, and I can use CA cert. Oh wow, this is getting really long. Is equal to ca.cert. I think that's the way. Yeah. Okay. So rather than getting SSL, I don't understand what that means, error anymore. I'm getting unauthorized error, which is a good step. But what that means is, well, even though now the connection is secured, I don't know who's calling the API server. I need to authenticate myself somehow. And to do that, we actually give you need to pass in your identity via a header, the authorization header. So we actually give you the authority or the token that you need to pass in, right? And that's actually right here in the same directory, and it's a very long token string that you can use. Okay. So what I can do then is I can use curl. I give it the CA cert, and then I can pass in the header called authorization, just like any of the, you can use basic or whatever. In this case, I'm going to use a bearer authentication, bearer type, and I'm going to pass in the token from the file. Okay, and now I can get access to the API. Then I can use the put and everything else. I can interact with the Kubernetes API server. Okay, so far so good. I talk about headless server. That's important. CA cert, yeah. So in this case, in my code, I'm using Spring Boot with Groovy. So I'm using a lot of these annotations and stuff. But here's the important part, right? I need to construct my own SSL socket factory to read in the CA cert file myself. Then all the subsequent REST template codes will be using this connection with the right certificate, so I can actually make these RESTful requests. And the way that infinite span works is that you need to, each of those individual nodes, did you realize when the new node joins, it automatically discovers all of the other node? Well, there's a discovery that's happening behind the scenes. So as a new node, I need to ask somebody, where are all of the other instances running? What are their IP addresses? And to do that, usually on the local laptop, they use Multicast, right? You multicast out on a network, and you can see who respond, and you say, oh, OK, that's where everybody is. On a production environment, you probably never get to use Multicast in most cases. Now in Kubernetes, right, because we have the API, we're actually using the API to do the discovery. So in JGroups, for example, Infinite Span, JBoss products, they always use JGroups behind the scene. So there's a JGroups plugin for Kubernetes. So rather than discovering things through multicast or a single node, you can actually use Kubernetes API to do this discovery. If you're running, say, something else like Hazelcast, the people at Hazelcast, they also created a, this is not the official one anymore. Oh, so they made this official. Great. So they also have a plugin for discovery to basically use the Kubernetes API to figure out where all the nodes are. Now, if you want to write your own, you can. Like in this Autoscaler, I'm writing my own stuff. But if you just want to consume it, there is Fabric 8, which I kind of mentioned in my previous talks. But not only do they have a full system that runs on top of Kubernetes, they also have plenty of nice-to-use libraries. For example, Kubernetes Client is one of their projects, and it basically takes away all the difficulties on getting that CS cert and authenticating yourself and stuff like that. All you have to do is to create this Kubernetes client. Then you can start to make calls to the Kubernetes API. It will auto-discover itself whether they're running inside of the cluster or outside, and it will try to connect and use the right certs. Okay? And finally, you can begin to think about all the possibilities, right? So for example, if you're writing Spring Boot applications or using something like Netflix OSS, you need a discovery server of some sort, right? Whether it's Eureka or whatever, Console, Zookeeper, just to know where all the endpoints are. Well, all of those information is in Kubernetes if you run it inside Kubernetes. So again, the Fabric 8 people, developers, they recognize that, and so they created Spring Cloud Kubernetes, which gives you like something like a discovery client that can discover all the endpoints directly from the Kubernetes API, rather than having you to need to run yet another discovery server of some sort. Okay? And they got a lot of other integrations here, which I'm not going to mention at the moment. Okay? So just so you know that these things exist and the API is really powerful, it's something that you want to really look into and potentially consume. Okay. Okay, so how is that autoscaler written? Well, I wrote it in Groovy, right? It's just a Groovy application with lots and lots of annotations. It's a microservice, yay. So the primary component here is that the autoscaler needs to know the conditions in which you want to scale in and scale out. And to do that, I need to know, well, what metrics do you want to see? And what is the target utilization of that metrics I need in order to make my decisions? And then it's like, well, if I need to instantiate a new instance, how do I do that? Which template do I use? Or which, in this case, replication controller do I use, right? And your capacity is limited by your infrastructure. What is the maximum possible instances can I actually run in this cluster, right? And of course, like I said, in this system, I don't want it to autoscale to 0. That would be bad, right? I don't want it to autoscale to 0 because I don't have data I cannot access anymore, and this whole autoscaling thing just become moot, right? Because then I have no metrics to collect, right? So I don't want to do any of it. So I need to set a minimum instance. Now by default, I can set the min instance to 1, and in this system, I'm going to set the min instance to 2. The metrics basically is composed of the timestamp, like when was this metrics collected, what is this for? Is it for the CPU memory or something else? In this case, number of entries. And how much is it being utilized, and which instance is this actually from? Okay, so I defined a lot of these POJOs with just annotations in terms of what I'm expecting in the data, right? And I have the mapping to receive that via the RESTful endpoint. Now I'm also using Lombok, and I'm using this SL4J annotation. Anyone using this? This is great. This is magical, right? Every time I write a new class, the first thing I write is public static final logger equal to logger factory new logger, right? So with this SL4J thing, it just injects this log into your classes directly, which is really easy to use. My autoscaler needs to wake up every once in a while to understand, to see what the current utilization is, because I'm not going to be doing this constantly. I'm going to be waking up every once in a while, maybe 5 seconds, 10 seconds, 1 minute, 5 minutes, depends on your workload. And in Spring, I'm using scheduled annotation to make this a schedule work, right? So it's going to wake up, in this case, every 30 seconds or so, and it's going to go through all the current metrics and utilization and figure out how much I need to scale. And the scaling operation, you can probably see here, I'm using an asynchronous operation because I don't want it to block in this case. So I can use the async annotation here to run this basically task asynchronously behind the scenes without doing a lot of extra work. To collect the metrics, I'm using something called Genomic strands. It's an open source project. And basically, it's a connector that can go into your GMX servers, and then you can write a few definitions and plugins and decide on how you want to export this, right? So I wrote my own GMX trans output writer that basically will wake up once, every few seconds or so. You'll go into my infinite span instance running in the same pod, grab the statistics, the number of entries, and I'm going to send it to my writer, my custom writer, that will then, basically do a post into my metric server. Okay. Now, once I have all of these things, once the autoscaler understands the current utilization, then it needs to make the decision on how to autoscale, how many instances to scale. There are different methods of doing this, but this is one of the algorithms I found. In fact, Kubernetes actually uses an algorithm like this, where they take the sum of all of the utilization divided by the target utilization, and you want to take the ceiling of that, right? Why is that? Just so you have more instance than what your capacity has, right? If your target number of instances is 3.2, you don't want to run it down. You always want to run it up, right? That's why you take the ceiling, okay? And in many cases, what you also want to do, I don't have it in the slide, but what you also want to do is by putting a buffer, right? Because you're going to get these fluctuations of utilizations. And if you do it all the time based on the target utilization, right, you won't be able to capture and respond to these variations in terms of the traffic. And by adding a buffer in there, it will protect you against, say, scaling in or scaling out too aggressively, right? So by default, what I'm doing is I'm only going to scale if it's exceeding 20% of the utilization, okay? Okay, so let's see how that works. I got 10 more minutes, so that's why I keep my demo to the last. Just so it doesn't work, I can just kind of disappear, right? And it kind of works all the time, yeah. So let me scale this back in. I'm going to scale this back to 2, okay? And then what I'm going to do is I'm going to kick off the autoscaler. So my autoscaler is also running as a pod inside of Kubernetes. That's my autoscaler right here. There's one instance running, right? Now just think back of all the things it's trying to do. It's connecting to the API server, right? It's going to use it for the actuator, as an actuator to spin up more or less instances, okay? So let me just wait for this pod to terminate gracefully. Now this autoscaler has logs, so I can do kubectl get log, wait. Okay, so I can do kubectl logs f. So I can see, kubectl logs f, the name of the instance. No, I don't want to see the definition. Here we go. All right, so I can see the logs here, okay. And it's telling the logs from the top. So it's gonna, all right, so it's caught up. So you can see the metrics is being pushed out by all of these instances, right? So this is what I'm going to do. I'm going to make a post to my autoscaler to give it the autoscaler configuration. And what I'm going to say is that, you know what? For the number of entries, I know the max I can have in each of the nodes is 100. And I'm going to say that you can scale to 10 instances max. You can come back to 2 instances minimally, okay? So I'm going to just post it. I'm going to post it via a service call to an external endpoint, which is here. Okay, so I'm going to say create an autoscaler. And if I go back to the log, I should say that the autoscaler is created, and every few seconds or so, it's going to say, do I need to autoscale? And this is saying we don't need to autoscale right now because the count is 100 on each node, perfectly within the limits. What then I want to do is to go to the app again, and let's see how it works. All right, so I'm gonna maybe give it, I don't know, 500. No, 300. Yeah, why don't we do 500? Okay, so if I put in 500 entries in here, if I need 100 entries per node, how many nodes do you expect it to have to serve this capacity? How many nodes? It's 500, right? You duplicate it, so it's 1,000, right? So if you have 100 entries on each node, that's 10 nodes, right? So you can see that this is adding and adding and adding entries. My autoscaler should be kicking in right now, right? There you go. So it's going to expand this. When you're scaling out, it's scaling out as aggressively as possible. CTL, get pods, right? So I can see that it's determining at this moment it needs 1, 2, 3, 4, 5, 6 pods, right? And it's collecting metrics continuously, and it's going to create more and more of these pods. So I should be able to see 10 pods in the end of this exercise, right? So, and also for the demo purposes, there you go. Wow, ooh, wow, too fast, right? And as you expected, I should have 10 nodes here. 1, 2, 3, I'm not gonna count. But you do see that there are about 100 entries each, right? Yeah, pretty good, pretty cool so far. Yeah, I like the colors too. So let's see what happens if I remove entries. If I remove entries, operation remove, I'm going to remove, I don't know how many entries. Why don't I remove 300 entries? What that means is I should have 200 entries left. That means duplicate it to 4, so I should have four nodes left, right? So I'm going to do that. So you can see the number of entries being reduced. Yeah, I got 5 minutes. Very good. Almost there. It's working so far, so I don't have to leave so early. Okay, now here's the tricky part. Here's the tricky part. What should the autoscaler do in this case when it sees, well, I know I just need 4. Let me just delete 6 instances at the same time. Not in this case, right? Because you only have 2 copies of data. So if you get rid of 6 instances at the same time, you're going to lose majority of your data, right? So in this case, my custom autoscaler actually says, you know what? I'm going to only get rid of 1 instance at a time. Hopefully only 1 instance at a time. So it's going to do this slowly. So 1 instance is gone. And because I'm shutting down gracefully, it should make sure that the state is synchronized, right? And then another instance should be going away, and so on and so forth. I'm going to leave this to the end because in the end, I should have 4 instances with 200 entries each or something like, or 100 entries each, okay? So I'm going to come back to that in a second. Okay, I talk about a lot of these things. Now, here's the thing. The metrics are being collected continuously. When I'm scaling in, the node will be removed. But my metric store still has that number. When I'm aggregating this average utilization, I want to make sure those deleted instances are not being accounted for anymore. So I need a way to kind of remove those data from my calculations of my utilization. Okay? That makes sense, right? Because I don't want extra data in there for instances I don't have. So what that means is my autoscaler needs a way to watch for deletions. And this is probably the best part of this API is, remember that curl that we did? Let me go back. This curl that we did. Let's see, I can actually curl for pods as well. Okay, this curl that we did, we can get this in a single shot, right? But if I want to listen to a stream of events that's coming in, I should be able to say watch is equal to true. And now I have a socket that's being kept open, right? That whenever new data comes over, I'm going to get a new record for this state change. Okay, so my autoscaler is receiving this in a stream. Yeah, stream is being talked a lot today at this conference, I think. So I'm receiving a stream of state changes, and based on these state changes, I can react to it. And when I see that something has been deleted, then I can go ahead and remove that data from my calculation. Okay. So if I go back to this visualization tool, I scale down to 4, and apparently, luckily today, I didn't lose any data. So that's good, right? So not bad, not bad. Okay, so that's all I have for today. I'm also out of time. So thank you very much. We went through APIs and tokens and CAs and watch events. And just keep in mind, I never written an autoscaler before. All right, thank you very much. Thank you. Any questions? Do you have time for questions? One question, if there's any questions.
Perhaps 2.
Perhaps 2, yeah? No? No questions? Yes, 1? Yes. Oh, I see. Yeah. So the question was, is there any reason for using the RC replication controller, which is a type of resource you can create, or replica set, right? Or in other cases, deployment. Well, just between replication controller and replica set, for me, it is because this was built before replica set came along. So I'm using replication controller. But now, going forward, you should always be using replica sets. And if you want to really manage the deployment properly, use deployments rather than replica sets directly. Yeah. Okay, but in essence, there's no difference between replica set and replication controller, except for the way that they can be queried. That's really it. Okay. All right. One more, if there's one more question? No? Okay, well, thank you very much.